feel like that's enough. Hello everyone and welcome into yet another live stream. Hi there, Happy. Hi, hold on, where is... There's my charger. So hi there everyone, how's everyone doing? Hope you're all doing fine on this evening, morning, depending on where you watch. And this is what I've got for us today in store. Not this one, we don't care about this one. What we do care about is this joystick, this brushless DC motor, this right here controller to the brushless DC motor, which is the one I mentioned last time was coming, and then I just realized I forgot the servo. Whoops. And then this right here servo. I'm salty hot today. What happened? Who was it? Whenever someone's salty, it's always those gosh darn haters, am I right? Let's play some music. This stream is dry already. Nothing a little bit of music can't fix. Oh, my File Explorer just crashed, never mind. I guess we'll not be playing music. Hi there, Bennett. Welcome. My file explorers keep crashing. That's never a good sign. Anyhow, today, here's the thing. As always, we have the ESP. Kinda, 2 streams one day for me. Really, is it? For me, it's after midnight right now. It's 3 AM to be exact. And I'm here streaming electronics. Oh, yeah. Isn't that fun? You can hear me, by the way. Right? Yeah, good, good, good. I also have a second ESP. Hold on, let me bring out the second ESP. I do also have a second ESP, which we could use as the controller, but I'm decently certain the second ESP might be ever so slightly burned. I don't know how I did it, but I did do it, so I'm just that good. Hi, Null, how you doing? I have not seen you in a while. How's life? Should I be more 1984-ish when it comes to these live streams, by the way? And just ban people who spam, or should we just let them have their fun? That's a great poll idea, let's do it. Start a poll. More 1984. Hi, the Tefta! Make it polls whether I should be more of a dictator. Hey! If I'm gonna make a poll about being a dictator, might as well do it democratic, am I right? I'm a good dictator. All of my polls about being dictator are completely democratic, trust me, don't double check the results, because there is no need. I love this I love this doing democracy to see if we should create a dictatorship. Yeah. Hey, if dictators can do it, then so can I. Oh, it took me a really long time to take that. Fortunately, I've ordered more ESPs, because of course I have. Why wouldn't I, am I right? I mean, we are getting dangerously close to 1904. Ha! Political! Because, I'm guessing you mean America, because America gave presidents full immunity, practically. Political, anyhow. And some more stuff, if I'm not mistaken. What are you doing? Oh yeah, right. So we have this ESP, which we will not be using at the moment because I screwed up the solder, and my File Explorer still isn't working. The problem is Windows is so dependent on the File Explorer that if it stops working, it restarts more than Explorer itself, which is a great feature. I love Windows so much. By the way, Tefta, would you like to hop in? You happen to have the time or... Right, a bit too loud. Let's quiet down a bit. There we go. Open multiple files and then just add all the files I have and then just play them in the mixed order. Oh, OddKit 2, the most groovy and funky one. What's the project? Bodyy Null to be exact. Bodyy Null, for which we'll have a turning system and we'll have a driving system, you know, something to actually push it forward. And so, as I mentioned, this one was common. This is the standard brushless DC motor controller, where you plug into the plus, plug into the minus, plug it into the controls, and then just control the thing. Pretty simple. And we're gonna try it actually right away. So first, plug it into the plus, plug it into the minus. Should be simple enough. We just need to plug it into the plus. It is some kind of outlet, but I'm not gonna. It's annoying because it's too big. If I had the nickel, am I right? If I had a nickel for every single time, I had that before. Right, consider it plugged in-ish. Then orange. And the Sero. Okay, consider it plugged in at least-ish. Then what we need is to plug it into the. I get circuits of these hourly streams out of computer science to make it. Thank you! I mean, this isn't really computer science. This is more. This is more electric engineering. Make it. We will be getting into computer science soon enough with this very Raspberry Pi Pico once I buy the USB for it. I don't have a USB cable that I can use. All of my money, fame, and riches, and not a single walking long USB cable.
That sucks.
Yeah, it really does. Hi, the Theft. How you doing?
Good. How are you doing?
Surprisingly well, I would say. A bit tired, if I'm being honest. Said that will pass. Yeah. Life, am I right? Money.
Yeah. Working all hours, yeah.
I hate John Money, invents money and then just disappears. Now we all have to live with money. It's horrible. Oh, without money, actually. That's the bigger problem, isn't it? Like, money is half the problem, but then, you know, not having money, that's the real kicker. That's where they get you. Where's my other two cables? I had them. I know I had them. Seconds ago. Oh, yeah, right. Okay. I couldn't hear anything for a second, so I'm hoping nothing happened. So, hi Steph, how you doing?
Good, good. You probably saw the images I posted. I made
Yes,
some
I
progress
did.
today.
So like the difference between what you do and what I do is staggering.
It's actually not that much. It's really close.
I'm connecting a brushless DC motor to a controller using jumper cables. I mean not the whatever grabby crocodile ones. It's
yeah,
a big
but you have all the
difference.
components. Yeah, but even the fact that you use, you know, the MOSFETs, like, that's pretty much everything. Like,
Okay.
more complicated or you know, I mean, you have all of the moving pieces, so to speak.
You know what's actually funny?
So,
I did order from AliExpress today. I ordered, I think it was 17 MOSFET based components. So it's basically like a MOSFET, except it has an input, the plus and minus input, plus and minus output, and it has a plus and minus input for the breadboard, and not the breadboard, only the controller, so that it works like a MOSFET, except it's way safer and way easier to operate. And I specifically ordered around 17 of them.
Nice.
Because they will work like MOSFETs, except without all of the problems of, you know, actually solving circuits, burning microcontrollers, etc, etc. So I specifically ordered them to actually use them like that. So for this, I wouldn't have to use a MOSFET, I will be able to use that, and then this can drive the thing. Alright.
That's awesome.
Yeah. Are you ready to try to, well, drive a brushless DC motor for the first time ever? Ever since I bought it months ago.
Yeah.
Ready to try it for the
I have not done this.
Yeah, neither have I. But I'm the one who has a brushless DC motor. Had for such a long time. I should get royalties every time someone says AliExpress. You know what? I agree. I agree with you, Ali. That's just valid. Right. boot, delete the whole thing. Oh yeah, I did some stuff with pulse with modulation. I'm so proud
yeah,
of myself.
I saw part of that. That's awesome.
It's-
Are you still in MicroPython or what?
I am in
What are
MicroPython
you
for the
using?
ESP. Yeah, for ESP I will be
Awesome.
using MicroPython, and I feel like I will always use I will still be using ESPs. My plan is to do logic with RP2350 and then do wireless stuff with the ESP. That's my plan at least. Because I could get a Wi-Fi module, but they are surprisingly expensive, and at this point I would just rather get an ESP.
Yeah. Well, what's nice with the RP2040 is that you have 2 cores, and the ESP that you have, the S2, only has a single core. So if you do any type of multi-threading, the RP2040 will be better.
I mean, if one day if I get to multi-threading, I'll be impressed. Because if you do multi-threading on microcontrollers, then you're entering basically levels of optimization. Oh, another thing which I think is comical. I'm certain I've already told you this before, but ESP32S2 mini pinout images
Yeah.
and first image. I'm sorry.
Yeah, someone else made one. Mine's the second. It's funny that they took my.
Wait,
took my
why?
line and cropped it.
Oh yeah, wait, they really did. They really did. They really did took yours and then just cropped it.
Yep, they did.
Oh,
I
that's
recognize those symbols on the wires because I made those waveforms on the wires.
that's
That one
mean.
isn't.
Oh, there we go.
No, it's CC0, Creative Commons 0 attribute.
Oh, seriously, it's still pretty mean to just crop out the made for open muscle, in my opinion. All right.
Yeah, they actually have to give attribution, but if they're in China, they don't, which is kind of interesting.
That's curious and also kind of worrying. The fact that I mean, I guess that's how the world works, depending on the country, different rules. Okay, what am I trying to do? Oh yeah, this is the third, so it's the right side. 16, 8, and 33. Those will be the pins. I am assuming wrong actually right now when I assume how this works. I just realized I should really look up how these controls work before plugging anything in. Okay, so brushless DC motor controller. Close enough. Put an amputated torso on the rotator. Wait, what's an amputated torso? I'm sorry, what's an amputated torso? User intent / level of make it and make incorporate. Anyhow, we just need to find the right icebreaker to get us started on talking about just the social political stuff.
Yeah, so right now I'm trying to delete the code and YouTube for the stupid heart icon in chat.
Oh, please, if you do, let me just give me the whatever. Oh, please, it's so annoying. It's so annoying. It's awful.
I got it blanked out, but okay, I will find this.
Subject. Oh, just give me the pin-up.
There we go. It's the ID is reaction control panel. So all you got to do is delete the reaction control panel.
Wiring and installation. That's not my kind of wiring. No. Brushes. DC
Okay, I
one.
got rid of the heart.
Controller.
So yeah, I built the brand new bracelet, and I'm calling it a PMG sensor as opposed to MMG.
Wait, what's the difference in this case? I know if I'm...
Yeah, so MMGs are low frequency muscle sensors that usually use microphones and like super small electromechanical things. And since I made my own, it's different and can't be classified as an MMG. So I decided to pull the name out of my butt and just call it a PMG for pressure. Yeah.
Oh wait, you get to make up an acronym. You can, I mean, you could go wild. You could make up something like...
Well, I did for the LASK already, the LASK for label
Oh yeah,
safety.
I suppose that is true, yeah.
And I'm like, okay, now I'm inventing the name of the sensor. It's like pretty cool. No one has a name for it, so I get to make it.
That is really cool. You do get to make it. Make it. Anyhow, is there a name for this kind of driver, or there has to be a name for this sort of thing? Because it's really, really common. Yeah, but there are two different kinds of BLDC drivers. These are
there's three.
Well, there's more than two.
Field-oriented control. It depends on the mechanism that the ESC uses to create the...
Oh, yeah, I think it actually is the conventional
FOC
ESC. I think ESC is like the... Wait. Yeah, that's the yeah, it's the default ESC. Okay. ESC pinouts.
Yeah.
There we go. Yeah, I'm looking. No, just images to make sure it's correct one. Then sensorless, yes, sensorless. How it works? Please do. Well, no, I don't care about this. Wait, pulse modulated? No.
Yeah, so there's trapezoidal control, 6-step commutation. There's a sinusoidal control, and then field-oriented control. Like it depends on how you're making the signal. It's like the output ideally is 3 perfect sine waves that are offset, and the one that's completely that way, I think, or as close as you can get, is field-oriented control. But it also has to do with how you're sampling the output too. So when I did research, because the only reason I looked this up is because of your other stream where you wanted to make one. And so
I am so sorry for wasting your time. Please do not look up stuff in the future because I mentioned them.
That's the only reason I know.
I don't want to make my own ESC. I'm over that phase. Give me the pinout for the ESC.
So yeah, you just have voltage plus, minus, and signal.
Voltage plus minus signal, you say? Oh, that would track with wire colors actually. Yeah, that would track.
So
but I should
it's the same as the SG90 takes. It's just like the SG90.
Okay, now the question: should I confirm it or should we just confirm it by trying?
Confirm it by trying, yeah. Because those are just signals.
All right.
So you're not gonna do any harm to anything.
Yeah,
the
I mean,
thing that could happen
my
is
lab
the
power
motor.
supply. Kind of scared.
Yeah.
My lab power supply is a chunky boy.
Just be ready to unplug one of the wires.
I'm pretty certain. Did I mention that I'm pretty certain I burned one of my ESPs actually. I'm pretty certain I burned one of them.
I don't doubt it. It's super easy to do.
Yeah, thanks for the confidence. I'm about to plug them into wires that I have no idea what they do. You're not filling me with confidence.
Well, the thing is those are low logic. Those are like 3 volt logic. So you're not gonna burn out. It's not like it's gonna accidentally send voltage through the ESP to the motors. Like that protection circuitry is built into the ESC. So you're as safe as the designer of that ESC.
I got it it's really cheap. I wouldn't trust the designer much in this case, but I trust you, so this is gonna work. Yeah. Pin number 16, if I'm not mistaken. All right.
But the thing is, this is where I use libraries, because you want to make sure, because what you're doing is whatever pulse width signal that you're sending to it, it has like a standard, right? So sometimes it's like a number in between 0 and 3200. Sometimes it just depends. So that's what yeah, just send a pulse to it. It'll probably do something. But controlling it specifically,
I mean, I'm just trying to get it to do something right now. Only once it does something.
so you're on MicroPython, you said?
Whoa! I've just turned my brushless DC motor into a buzzer. That's a skill
Nice.
I didn't know it was a thing. Alright, well, let's try 1 ampere for now, just for the sake of not electrocuting myself, let's just say. And pin... Yes, I'm MicroPython.
Okay.
Oh my lord, I am outstanding. Okay. So I have this magical...
Duty.
It's spinning.
Nice.
So I have this magical ability where I bring things to life. I'm not saying, you know, I'm a god. I'm not saying that. But I mean, there's no way I'd dig myself out that hole, is there? These are all jokes for them watching. You just remember that, please. Please don't leave.
So sorry, I'm actually reading while I'm listening. It looks like it takes a signal every 1 to 2 seconds. 50 hertz. They can't math that well. But
Wait, 1 to 2 seconds, 1 to 2 milliseconds.
well, they say 1,000 to 2,000 milliseconds, but that's 1
Okay.
to 2 seconds.
So that would be frequency of half a hertz.
They say 50 hertz. So I think you want
That's-
a frequency of 50 hertz, and then your duty can go in between 0 and 1023.
Yeah, that's the default on pulse modulation. So,
Yeah.
oh wait, so it goes all the way. Okay, that's convenient. For servos, it's different. For servos, it's from 40 to 115. So if it goes from zero, I mean, there's an easy way to test it, I suppose. I can just, well, just try it again. So turn it on. It's just upsetting that you all can't see exactly just how well it's
Can
working.
you put a piece of tape? Can you
Yeah,
put a piece
that's
of tape
actually what I
on
was. Why is it? Quit beeping! You're not meant to beep! There isn't a single component in there which has the capacity
beep?
to beep!
The whole thing does, because it vibrates.
It sounds
Right,
like it's
that's
coming
kind
from
of-
the motor, but it's so high pitched.
It is probably coming from the motor.
That's not a good beep.
Like those. Well, you know, like the coil whine in GPUs. Like at first, I was like, well, that can't happen. But if you think about it, those coils are electromagnets, so they're actually vibrating based off of the frequency of electric pulses going through it, which is kind of
That's
crazy.
such an advanced piece of like science to explain why something is beeping. Okay, I'm
Yeah,
turning
so,
on.
so literally, because the field is at a frequency.
Okay,
it's
so
crazy.
if we change the frequency of PM to 50. Oh yeah, this is the motor beeping. Okay, oh, don't break. Hold on for a second. No, okay. And then what was the 4-letter word for it?
Duty.
Duty. Okay, yeah.
Duty.
All right. 50. No. 0. No. Oh, beep twice. Oh, beep more. 1,000. 200. Okay, I'm gonna need to go see some documentation. Okay, turn it off.
Yeah, what frequency?
It's
I don't know.
it's terrifying. It's a beeping it's terrifying. Okay. Also another thing I love is what's it called when you represent like an we've just been talking about this. I'm having trouble finding words at this point. It's been a long day. When you just have single letters to represent like a phrase. So for example, acronym, yes.
An acronym.
It's so funny how many acronyms I'm just using at this point. Like right now, hold on, let me look up BLDC ESC PWM.
Yeah, standard. Yeah. Well, it's funny. Yeah, that's why I tell people. Like, I know a lot of people that are in the medical profession, and I tell them that computers are like anatomy. There's just that many terms you have to memorize, and all
I feel like
the terms have subterms, so they're usually acronyms. So it's like a million different acronyms.
I myself feel like medicine is better, actually, because when it comes to medicine, I've already mentioned that medicine is the most well-behaved science I have ever studied. It's a lot. It is a lot, but it's really clean. It's a lot, but you won't really have a trouble learning that lot. It's really clean, really nice. When it comes to electronics though and computer science, unfortunately, programmers, computer scientists, and people who do these sort of things in general, most of the time they have a bit of an ego. And when they name things using these acronyms, sometimes something which could be described very well in a single word, sometimes it gets extended to like 5 words, So just electric photon emitter instead of saying a flashlight. Okay, I am not interested in how it works. I am aware of how it works. I'm looking for the standard. Selection of PWM switching frequency in BLDC model. That's electrical engineering stack exchange. My beloved. Okay, I was just looking for a simple answer. I wasn't actually looking for a detailed. Oh wait, did the jumper cable fall out? No, it's still beeping. It feels like I'm sitting here with a bomb.
So it looks like it's 5,000 for the PWM frequency. Try 5,000.
Okay.
And then try duty 100. Yeah, like 50.
It's still beeping. Can you hear it?
I can.
It sounds like it just sounds like a bomb.
Yeah.
It sounds like I'm sitting here with a live grenade in my hand, waiting for it to explode. By genius idea, make it just plug it in first and only then look up how to do it. Signal standard for yes, I'm looking for standard ideally. Because okay, only extra value right servo from 100 servo control BLDC motor. Okay. Oh, lovely graphic. I love it. Oh, I absolutely love it when people make graphics like that. Shout out to Tefta. So 20 milliseconds apparently in between, and maximum is with. It appears to be the same as servo actually.
So what's the frequency?
It should be 50.
Okay.
Okay. If I burn a brush DC motor, that's gonna be impressive actually. If I manage to burn a... Okay, it beeped really aggressively and I was not spinning. So 115 should be the maximum. Oh my lord, it is the maximum. Okay, slow down, slow down, slow down to 60. No, that's 600. My hand is shaking. That's powerful. Wow. You all can't tell just how powerful this. It's spinning quick. And that's on 60. That's on... Okay. So it's the same as servo. Good to know. 50 turns it off. Alright. Well, we learn something new every day. Oh, that's terrifying. So here's the thing. Because the reason why I'm doing this. Oh yeah, I should mention. Remember Bodyy, Tefta? Bodyy I've been making?
Yeah.
Yeah, so I want to make Bodyy Null before I move on to Bodyy Alpha. Bodyy Alpha I actually want to be cool. Bodyy Alpha I want to make something which people will look at and be like, oh yeah, that's actually really cool. Not kinda cool, really cool. But not that first Bodyy Null, which is the learning exercise. And so I've made a couple of iterations of Bodyy Null. Right now I have made 4, and all of them sucked. But for iteration 5, I do plan on it actually working. That's why I'm switching my methods, and instead of doing a quick temporary thing, I actually want to try and do something that works. That's why I will have a single engine to actually power it, which will be the first. Well, a single motor to actually power it, which will be the first, and then use a servo for switching it, for turning it around. That's why last stream I tried to figure out how the servo works. And
Yeah.
the motor I wanted to use was this one, simply because it's the only free one I have at the moment that could possibly power it. And this is a really big one. This is the one that would normally be used in electric drills or just electric tools of any kind. I genuinely feel like this one might be stronger. Having run both of them, this one feels stronger.
Well, it might have more torque.
Here's a size comparison. To be fair, I could make this one have more angular momentum. But so far, just from the controls, this one is terrifying.
Yeah.
Let me see, because I'm really not doing it justice. Let me see if I can, like, show you just how truly terrifying it is. 80. That was 80! The maximum is 115!
Yeah.
Oh, it's great. I love it. I love it so much. Why didn't I buy it? Why was I trying to make an ESC? I'm an idiot. Tefta, if in the future I ever want to make a part which could be easily bought, just remind me I'm an idiot. Yeah, you have to be more rough. You have to just use the word idiot next time.
I'll think about it. I'll say that the idea is idiotic. I don't like calling people idiots.
No, I mean, to be fair, back when you told me an ESC, I still think I did the right thing, because the reason why I wanted to make an ESC wasn't because I thought I could make a better one. I just wanted it as a learning exercise.
No, it's a great learning exercise.
It was a good one, yeah. It paid off,
actually,
in my opinion.
Well, and I learned something from it too, because that was stretching my abilities like to the max.
Yeah.
I don't.
Right now,
I know
feel
in theory how to make one, but doing the research helped me to learn as well.
yeah. For me, basically making my own controls. Right now, I can use MOSFETs perfectly, and I feel really confident working with MOSFETs. On the very beginning, they were witchcraft, and I had no idea how they work. Right now, I feel really confident working with them. Oh yeah, right here I have taped something, by the way. I don't know if anyone noticed. Do not spin the things out very fast at 3 AM. I mean, you all saw how terrifying that was, right? This is a joystick, and that's because I knew that this would be quick. I mean, it's a finished part. Just plug it in, get it to work. So what I thought we could do is... What happened?
It's not that easy.
You mean with the brush, this one?
Yeah.
I mean, it works.
No, with the joystick.
Oh, with joystick, yeah, I know. No, I meant the finished part, the DC motor controller. Brushless DC motor controller is the finished part. Yeah. So what I mean is that the brushless DC control, I knew it was gonna be so easy to set up. That's why for the meat and potatoes of this live stream, the actual meat and potatoes will be the joystick. So I know how to drive the servo, I know how to drive the brushless DC motor. That's why the joystick will be the boss fight of this live stream. So don't worry, I'm not disrespecting.
Because I think there's 2 potentiometers, right?
Yeah.
That's how they operate.
From my understanding, you plug in the voltage, you plug in the ground, and you basically have 2 potentiometers which give you the voltage from them. And I think voltage. Yeah.
So you just need 2 pins to read an analog signal.
Yes. I have never read an analog signal on the ESP.
Fun. That's the coolest thing about ESP32s is that they have like, I think it's 16. Yeah, like this module, you don't actually have access to all 16 of them. I think it's 16. And of course, there really is only 2 ADCs. It's just multiplexed, right? But to have that many pins to measure an analog signal, that's awesome, because you usually pay a lot more for a component that will translate it to like I2C or something. Because it used to be that ADCs were very, very expensive if they were on a microcontroller. But now you have like 16 pins. You can measure 16 different things, which is just, that's why this chip blew my mind, because you can put a 15-cent sensor on it and make it work.
It isn't, Sandy. The idea of microcontrollers is insane to me. It genuinely upsets me sometimes how people don't realize how amazing microcontrollers are. What microcontrollers basically are is you basically like, okay, So you have this thing with which you can automate everything, and setting it up to automate takes like 5 minutes. Actually connecting it to automate takes like 10 minutes, and you can genuinely automate everything. People don't get that. Like, oh, you want your, I don't know, coffee maker to make you coffee at the press of a button wirelessly?
Yes.
Yeah, sounds
Yes.
like an extremely difficult thing. You can do it in 2 hours. And that's 2 hours
Yeah.
factoring in for the fact that you'll probably forget about something really simple and then you have to spend an hour fixing it.
Well, if you think about home computers in the 80s, like the Atmega, I can't remember the names of them, but the Commodore 64 and the crazy weird ones that were before my time, this is as powerful as those.
Yeah, it's
Like,
insanity.
It has more RAM. It has more RAM than those had hard drives.
I was like
So,
talking with someone
if you
very
think about
recently.
it, in 40 years, a microcontroller would be like having a laptop the size of a stamp.
I mean, not
that you
really
just
even, I wouldn't even say
switch.
in 40 years. Like, our last Satisfactory live stream, we read about the rule. The rule about
Yeah,
how quickly it's
Moore's
going.
Law.
Yeah, Moore's Law.
Every 2
Actually,
years.
how many transistors, because it was about transistors if I remember correctly.
Yeah,
How
transistors
many
in a given.
transistors does RP2350 have? I don't know, I don't expect a full number. It's, no, it's
Isn't it
2350 already.
RP2040?
No, because this is the newer one. They released very recently. And by very recently, I think 3 days ago. It's really, I mean, I'm already waiting for them. It's funny because you can't buy any, because no one's made them yet. So I'm still waiting for them to make it, pun intended, and then for them to come.
Dual M33s. That's cool. I wonder what else it has on it. Check
Oh, it has an AMD and an RISC-V architecture, which is, I think, really fun.
Yeah, risk fees.
The idea that you can have 2 architectures on a microcontroller, I just find it just cool. Alright, ground is the second one, powers. Oh, these cables are awful. That's what I get for.
Oh, I hate this Adobe Reader. Where's the next page? Oh, okay.
Oh, and then what does SW mean? Oh no.
Usually the clock. SW? What do you mean?
There's an SW on the joystick. SW pin.
Oh, it could be the push button, the switch. When you can you push the joystick?
You
in once the
are
button
right,
makes it?
yeah.
Yeah, there's probably that.
Okay, yeah, that's exactly it. Wait, then this could actually be simpler than I was expecting. Well, I have no idea how to read stuff, so, you know, my expectations are still pretty vague, but... Pin, and then... in 0, and then in 1. Pin, and then which pins are they? Which pins are there exactly? They are pins number 16 and 18, if I'm not mistaken. Wait, can they read?
Oh, so 2 I2C, 2 SPI, 2 UART, 4 or 8 ADC channels. Yeah, because the normal one had 4, so there must be an upgraded one with 8. That's pretty cool. Because the problem with the RP2040 is that it only had 4 ADCs, and one of them was tied to the reading the voltage of the device.
Yeah, I remember. I mean, I remember I learned about it in an unexpected way where something wasn't working and I realized I'm an idiot. That's because of that reason, but I've never actually gotten far enough for that to be a problem for me. Wait, so Is ADC... Wait, which pins can read?
The orange ones. The orange ones.
Alright, see. Oh, that's convenient.
That's
That's
why I
actually
have all
precisely
those orange on my diagram.
what I plugged in.
Yeah, and 2 of them are DACs.
Oh no, I mean, I really appreciate the color. I was just asking which color corresponds to what, because I've already used the... because I've already... The colors already helped me with PWM, because I wasn't sure which one, so having all the PWM pins highlighted... Well, these are all of them, but knowing that they're there, it was really helpful.
Yeah, I made it for myself because that's what I'd be like, oh, okay, which ones are ADCs? Because I want to route them, making a custom PCB, so... And then I also have the wavy in the line. But no, that was for PWM, never mind. Wavy lines meant PWM.
That's a really nice graphic. Alright, let's run this, and then... shocker, absolutely nothing happens to be expected. That's because we don't want to be reading value, we want to be reading the thing. ESP32S2 mean, oh, not mean, it's ESP32S2. Reading voltage.
Oh. I could just send you a link.
Want to make it is making right now. Bodyy, as I mentioned. Actually, if we get, I mean, if we get done with this on stream today, like as far as electronics go, Bodyy is finished. The next thing, all I'll have to do is just I'll have to finish the body to body tomorrow, and then.
Yeah. Huh. Oh, there we go. Ohm 12. So here's a link to what I did. And where do I initialize? Yeah, line 112.
112. Print hole, array hole.
So I put variables into an array for 18 ADCs.
So the array hole?
Yeah, hall. Because I had multiple array.
Dot ADC. Oh, I see. Okay. I get it now.
Yeah. And then I also, the attention,
So this will
ATTEN, it sets the decibel rating. That's the second line that you'll need. It's line 117. Because when you initiate an ADC pin variable in MicroPython, you can tell it how big the signal is going to be. It can only read 0 to 3.3 volts.
So,
right? But
would I set it to 80 attention? The same as
11 decibels, like I have it.
All right.
Yeah. That should give you the full range. So you're just gonna actually read the voltage. So whatever value you get will be true to its voltage at that.
ADC has no object value. That makes sense. Okay, now whole erase of y. Now if I want to read it.
Yeah, so then that variable, whatever variable you assigned it to, just type in the variable name .read.
Read, I see.
And I think it has, let me, it's a different line.
Okay, so it's not working, but the pins are awful. So that might be actually for the pins. I mean, jump cables. They are really, really bad. I'm just going to plug into these. So much better.
Yeah, it's just .read. There's lots of different things that you can like .read microvolts, .read whatever. There's like 4 different things.
It is really cool how this is basically practically a multimeter. On the microcontrollers have like an insane amount of functionality in them.
People made them into oscilloscopes.
Yeah, it's a microcontroller. It like by definition doesn't really have a specialized purpose. All of these are on top of it being just a general thing.
I think it's at 150 megahertz too. So, but you can only sample so fast. Like in MicroPython, the fastest I could sample was in 10 milliseconds. I think it gets close to like 100 samples per second across all ADCs. But I think the limitation was mostly how many cycles it took my code to run, right? So,
I mean, at some point, that really will be, huh? But then multi-threading.
Yeah, which is so cool because in the coffee clicker, I have multi-threading, so I'm able to read and write at the same time. Because I'm sending a Wi-Fi signal and listening for a Wi-Fi signal and processing data.
I just want you to know that you're amazing, in case you don't appreciate that enough, because using multi-threading in the coffee clicker is such like a professional move. It's such an expert move.
Well, then my stupid self decided to make it blockchain too.
I mean,
it wasn't hard enough, apparently.
Over engineering, and I can't even get a joystick to work. Okay, it's plugged in this time. It should be plugged in.
Oh, it's reading.
Yeah, but it's reading. But I've made a random number generator.
So yeah, that other one is reading max, which is interesting. High voltage, that 8191. Because that's the max reading you can get.
Bad.
So it's like it's reading just the plus voltage, like 3.3 volts.
I missed pins.
Wait. Okay, I have to tell you, what pins are you using?
16 and 18.
18 is bad.
Oh,
by the way,
I see.
Because 18, you see how 18 is tied to a DAC as well, the green thing?
Yeah.
It turns out that the Wi-Fi chip uses pin 18 to do the pulse width modulated Wi-Fi signal, right? And so there's some bleed over on this specific dev board from pin 18.
I have heard that actually.
Because of that. Yeah.
I have heard about that. Okay,
and
so
I think in one of my updated documents, I pointed that out. But
it's a bit of a pickle because that means I need to switch to pin number 15. No, it's soldered.
but you
Okay.
don't have a header.
I do not know.
Oh,
How about pin number 3, which will be this one. But just for now, I can just hold it. Oh yeah, and maybe make it switch it code-wise too. That would be great. So pin number.
So this is a good tactic: is read those 2 pins before you use them. Make sure that they're showing just a nominal voltage with nothing connected to them.
Okay, it was kind of silly of me to hope that this would work on the first try. Right, joystick pinout. Joystick pinout tutorial how to set up. Is there like an easier way for me to problem in Tony's backend? Well, yeah, is there like an easy way to keyboard interrupt? Because sometimes it does glitch.
Control C times 2.
Yeah, I just had to press it 8 times for it to actually stop, and then Tony just gave up.
think you could do Control D as well. But yeah, that's kind of glitchy.
Okay, hopefully we also don't forget to give a great design. Bodyy Null will be beautiful. And I do mean genuine beautiful. Oh, that appears like the exact thing I need. Yeah, I
I want
don't...
to show you what I did today. Discord. Uh-oh. So this is, for the first time, I had to route my own
What?
traces
That's...
on PCB.
Wow. Wait, you did that manually?
I did. Yeah, because I had to make sure that the signal lines were routed properly, because you actually want to make sure that there's not... Those are the most important.
I just want you to know that I'm sitting here in shock and awe, because... I mean, it looks insane. It's amazing.
That's what I did today, on top of making the Open Muscle dev kit version 0 PMG sensor 12 band.
That's really, really cool.
Yeah, and I'm using the ESP32C3 on this one that has the 2 cores. So that way I'm gonna control the whole band just by the label system. I'm gonna use multi-threading, so that way I can get the signal from the Open Muscle band and send it all from one device. So there should be lower latency.
I honestly would love to learn electronic just so that I can do like Open Muscle live streams with you.
Yeah.
No, I thought
that's awesome.
Yeah, I can even get the joystick to work right.
Well, first,
I thought the pull-up was the issue, but it's not. It's the
so
problem
does the
because...
joystick have a light on it?
No.
Usually...
No, it doesn't appear to. I think the... Oh, voltage might be not high enough. Actually, yeah. Yep, voltage might not be high enough. Is there a single pin on the ESP which would give 5 volts?
Only if it's plugged in via USB. The V-bus line would give 5 volts.
Oh, then it has been plugged into V-bus actually.
Yeah, so as long as the ESP is plugged into USB, the USB is actually supplying the 5 volts to the V-bus channel.
Yeah, I think I might be having another problem.
What's that?
Because, I mean, correct me if I'm wrong, maybe I am mistaken in this case, but I'm pretty certain whilst the V-bus can give you 5 volts, the ground pin can't. So...
No, the
that
ground
could
pins
have been the
usually
issue.
are 0 volts.
Usually.
It depends. It depends on the circumstance.
Okay, now it makes a lot less sense.
Wait, is it doing anything?
No, not exactly. Although these jumper cables don't feel stable.
So this is what I would do, right?
That's the very annoying bit of making things, at least as a beginner.
Are you really? Because the
so many
joystick
points of failure.
has the pins on it, right?
Yep.
It tells you.
Oh, I could just plug it in.
Which.
Wait, can I just plug it in directly? I would need a different...
Yeah.
There is one more thing I could do. I could just plug it into an external power source with the ground going back to the ESP. That may work.
So it says VCC is on the top. Then it's...
Oh, in my case it's ground. In my case it's ground, then 5 volts, then the measurements, then the button.
Okay.
Yeah, so the orange, which is the ground, is going right here into the ground, which is the second pin on the ESP. Then right here, the voltage going into... All of them should be right. But also...
You have a multimeter, right?
Yep.
That's I use your multimeter
I
to
will
make sure
just
things are connected.
try one more thing before I do. Just a bit of a yes, but
Because the multimeter is my best friend. Yeah, you can do it that way. Put those directly onto it. That's smart. It ensures the proper connection.
yeah, and this is now properly. No, it's backwards. Now it will be. Can you hear me well? By the way, I'm moving really far away from the microphone. I'm so sorry.
No, I can hear you.
Now it should be properly connected, except for this one, which doesn't have a place for it. Well, except pin number. Nope, there are no more pins on this side which could work. All right, well then I guess we'll just measure one. Oh, it works on one side, I think. It's. I mean, it switched to something so drastic that it had to be it.
Yeah.
And also, once again, Control C just.
Well, the thing is because it's delayed, right? So when a program is running,
I should add a sleep, right? I should add a sleep right here.
Yeah, time.sleep. That way it controls it. And I also do in the boot up sequence, I add usually something for 3 seconds for this reason, that when I'm trying to connect to a, because if you're dealing with a single core microcontroller and you have a read, evaluate, print loop, which is what we see in the bottom left, and you're running code, not only is it running code, but it's also listening for the user to type something from Thani. So it's not multi-threading. So it's kind of impressive that. Yeah.
It was working. Oh, it is. Okay, if we go down, it goes to 5. If we go up, it goes to max. The problem is in between it has 7.5, which... Yeah, if I move just a little bit forward, it goes straight to the max. If I move, but backwards, I've got full movement. So, should I switch 11 decibels to something different?
Well, if you're giving it 5 volts, instead just give it 3 volts.
That is also a smart idea. Alright, so other side basically. Just
yeah, give it only 3 volts, or you could put a resistor in between them, but for the sake of simplicity.
For the sake of simplicity, I'm just gonna do it like a professional and just add a cable to go to the other side for the free.
But look at this. The other one is still high, even though there's no electricity.
Yeah, because the other one isn't plugged in. Yeah.
So now it's at 5,000, and when you move it, it goes to 8, and then goes down to 0.
8, 5, 8, 5. Well, one side is working, yeah. Now for the other side, I'll once again have to do a trick with cable.
Solder some more pins.
I could, but this is quicker. I am childish. I'm just going to.
You have to hold these 3 wires in order for the robot to work.
Yeah, I mean, okay. In the end, I will
like
solve it. No, you just, I just give you a lot of freedom. You can control it however you want. Like, oh, you don't want to use pin number 3 anymore. You want to use the pin number 7. Go right ahead. The code won't work, but precisely, it's working. Yeah.
That's awesome.
That really is awesome.
Look at that. Now you have a 2-axis controller.
And now it's really cool. Well, now it's time for the cool part, which is connecting this with the servo, with the brush. Oh, but no, I see a problem in my plan. Okay, what should I do? Should I now solder everything together, make a working prototype, and then make the 3D printed design for my solder, or should I make the 3D printed design and then solder it for that design? So should I print for the circuit or make the circuit for the print?
Well, what's the so like if I were you, are you gonna make a printed circuit board, or are you just gonna use
No, I'm just gonna use cables. I do
breadboard?
plan. No, I won't use a breadboard. I'll just use cables.
So I was thinking you could just have a small breadboard on the robot, and then it would all be in one area.
I do have a
And
small
you could just
breadboard.
slot a header pin.
Give me a second.
Yeah, that's what I would do, because then you could still adjust it and make minor differences, and it makes it, like you said, versatile.
Listen, you had me at that's
and
what
it
I
also
would do.
holds all the. Yeah.
Alright, give me a second.
So for my quadrupedal robot,
Yep.
I actually have a breadboard that I left.
You know what? This one. Give me a second. I'm gonna go for the tiny breadboard. Just
Sweet.
go. Just go. This and Alright, I'm back. It's really tiny. It's a tiny thing.
There you go.
Barely bigger than the ESP. I also brought a soldering iron with me. Although I did not bring any soldering material. That's fine, you can just warm up for now.
That's a tiny breadboard that you can have pretty much everything on.
I mean, it's pretty average size, but yeah, let's, for the sake of simplicity, let's call it the tiny breadboard. There we go. That's the soldering iron. I have learned to spend more money instead of just trying to fix problems which could be solved by just buying the correct part. You know, give me one more second.
Yeah.
I do need to go for the cable and the soldering bits. Or cables.
Sadly, it is pricey to get
This and
into electronics.
Where else do I have any? So I should also another thing. No, nothing. Oh, that. Oh, okay, I'm back. Another thing, I should buy more cables. Speaking of, I got this little red bit and then
You should
triple
buy
cord.
solid core wire. I'm just telling you.
Wait, what is a solid core wire?
Solid core wire. It's like their male-to-male jumper pins. That's what they use in school for people that are learning electronics. It's solid core wire, and that's how I do all my prototyping.
I just never knew what it was called.
Yeah, so it's a solid core, and yeah, I like that one on the left where it has all the holes and the different colors. That's exactly what I have. If you scroll down, yeah.
I saw it. I didn't know
Whereas
what. Yeah,
white,
I really
green,
should.
Yellow, that's what I have on my desk, because you strip the cable and it's a solid core, so it sticks right into the breadboard. So it's a male-to-male jumper pin.
Oh,
Right?
yeah, I'm
So
going to.
That's how I connect everything. Yeah, it literally, the only reason you need threaded wire is like if you need some mobility. These are more rigid, but you can, yeah, it's.
I do
like,
have a solid core, but my solid core is
super
too
awesome.
big to stick into a breadboard. So,
Yeah. So this one should be the perfect size.
alright, now it's time to make the thing. So, powering the ESP. So, ideally, that's the problem actually. Because ideally, the ESP will not be connected to a USB, which means that it
Yeah.
will need a power source. So the same power source which will be powering the servo and the brushless DC motor.
So since you have a brushless DC motor, I would suggest an 18650. Because an 18650 has enough amperage. You can pull like, what, 4 amps from them, probably, pretty easily.
Wait, what's 18650?
So So 18650 is a battery size, actually. So 18 millimeters by 65 millimeters. It's what is used to be in all laptop batteries for 20 years. They look like giant double A's. It's all one.
Oh, I see.
18650.
Oh, it's this one.
So those, yeah, and they also have 18350s, which are cool. They're very cute.
Wait,
That's what I use
3.7 volts?
No, yeah, these are all 3.7 volts, right? So they're single cell 3.7 volts. So they're pretty simplistic in charging. I
Wait,
end up
actually-
buying a lot of charging.
What? Okay, in this case, I'm not gonna lie. I would really like to walk with what I got. So I don't think I have them, and I'm pretty certain tomorrow is. Wait, is it Sunday or Saturday tomorrow? The days are blurring for me. I'm working nights
Me,
these days.
Tomorrow's Sunday. Oh, okay. So you have those double A's. and you
I have double
four of
A's,
them.
and also I have the. Let me give me a second. I also have. Okay, so I also have these, which I think could be.
Okay, yeah. So those are just small ones. Those look like 250 milliamp hours. What do they say on them?
150.
The number mAh, 150 milliamp hours. So that will not get you very far. So the ESP32 on average will take 50 milliamps. So if that's 150, just the ESP can be
Last-
charged for 3 hours. So it can run for 3 hours
Well,
because that's a 150 milliamp hour battery. And
if it
the
runs for
Raspberry Pi-
3 minutes, I count it as a win. Bodyy Null is a
No, but-
it's
that's it not doing anything idly. It can go upwards of 100 to 250 if it's processing, right? Then you have the actual motor itself, which is going to draw so much amperage at so much voltage. So you might get about 3 or 4 minutes out of one of those. Maybe less. If you're going to use those to run the BLD, the brushless motor.
okay.
The problem is, yeah.
There is an alternative. I do have this, but this is really high voltage. This is, I think, 5.5.
That's good. Well, that wouldn't be 5.5. That'd be 6. Oh, yeah, it would be, depending on how depleted the batteries are.
Yeah, this one. It's ranges from
You should
6
be
to-
fine. That's what I would use, is those 4 AA's, because at
Okay.
least you have enough juice to run the motor and the Raspberry
Once
Pi.
again, you had me at that's what I would use. It's just
Of the 2 options, because the other batteries, if you wired them all up together, it's like you're never going to be able to charge them.
that's the
You
exact
have
problem.
to have a
You know
custom
what's
charging circuit.
really annoying with these? I have a charger for them. What's really annoying is that they only make sense with a charger, but I can't find a single cable which connects to this.
Yeah,
I thought I found it. I bought it.
those are
It-
JSTs,
really expensive.
but yeah, and there's different pitches of them too. So there's 2 millimeter pitch, 2.54
Yep.
millimeter pitch. You have to get the right pitch.
And so I love these and I absolutely hate these because whilst yeah they're rechargeable, that's convenient, I haven't really even had a chance
You
to
can buy a
decharge
box.
them.
So you can buy a box of JST. Those are just called JST headers or JST somethings. But they give you male and female ones, and you can make your own cables. You have to buy a crimper though. I have a crimper for those.
Like yeah, I feel like I
So
should
I
just go
can-
with batteries in this case. I'm gonna do the
Yeah.
smart thing actually.
So I had to use 4 of those today, and I decided to buy them even though I had all the supplies to make them, because it would have been faster to just buy it.
Okay. Whoa! Stay connected, please. I beg you.
But I better get going, I guess. My significant other is telling me.
It's fine. Don't let me keep you Thank you. Thank you so much for the help.
Good luck.
And I hopefully will finish it.
Good job.
Alright, bye. And there we go. We are alone. Now, what we need to do is we need to solve... should I solder the pins? I mean, at this point, I don't think there's a... point soldering the pins. They would probably just get in the way. Okay, what do we need? We need the joystick. We need a plus for the power supply, and so a positive for the power supply and negative for the power supply, to which we need to connect the brushless DC motor, to which we need to connect the servo, and to which we need to connect this and this. So every single component has to be connected to the plus and the minus, and only then we can control from... I feel like, okay, connecting the plus and minus, I feel like we should do it with the crocodile cables for now. And then, once everything is soldered control-wise, we can test it out and then we can see how it goes. So, right here on the joystick, well, now we'll just do 16 and 3. Pin number 16 and pin number... Oh, pin number 16 is right here. Well, it's orange on the thing, so 3 and 5. 3 and 5 should work just as well. And 5, okay. I don't have a cable that's right for it. Wait, I'm an idiot. No, we do not want to solder these together. No, the joystick has to go for the controller. Oh, that would have been a bit of an whoopsie, you know? Oh, thank goodness I reminded myself in time. Yeah, that joystick has to go for the controller, not this, obviously. Okay, good, thank goodness. So, yes, now let's go for this one. And let's solder all the appropriate bits together. So, brushless DC motor, we'd like to solder to the brushless DC motor controller, obviously. We will need to probably cut these wires, and these connections are really odd, actually. I mean, I'm assuming there's a stand for them. I don't have it, so I feel like cutting them and soldering might be a way to go in this case. Can you control body from afar, make it? Yeah, that would be the idea. So we'll have one ESP that will be connected to this motor and this servo, and then we'll have another ESP which will be connected to the joystick, and the basic idea is we'll use this ESP connected to the joystick, we move the joystick, and then they wirelessly communicate, and this ESP is connected to the motors, which means we can wirelessly... So the basic idea is move the joystick, and this joystick wirelessly moves the motors. That's the basic idea, what we're trying to achieve. Okay, so in order to do it best, I think I should just cut them and solder them to the brushless motor. Some people will be upset for me, some people will just be upset that I do it instead of just connecting them, but I am more about it working at all than it working properly. So, IRL video games, yeah. I mean, yeah. Oh, that's a good cable. Damn, that's a good cable. It has a silver color to it too. I don't think it's real silver, because that would be pointlessly expensive. Now all we need to do is just line them up. I might solder my table a little bit, but I don't care. Not important. It is important soldering these two together. And another thing, ooh, thank goodness I remembered. Another thing I should get is this thing to do it properly, which will be our heat thing, which shrinks when exposed to heat. Okay, put it on. Yep. Then we can Well, the other one. And then what we want to do is take the soldering iron. Yeah, I'm soldering it directly on my table because, well, because I'm just that good. There we go. So I can come back now, like this. And one last thing. One last thing being the lighter. Lighter? I barely know her. Cool. Bring it up. Yeah, proper. Proper solid, like it's meant to be. This on, so I won't forget. And then second cable. That is a really good cable though. Really is. Well, I can get the music back up because it has been quiet. Because I wanted to hear theft and all the music, but now music came back. Alright. Soldered them completely backwards. Sweet. Which means we should actually get this one done now. Pum, pum, pum. Okay, how are we looking? We are looking rock solid. It feels comfy of the music. Sometimes the music makes the stream feel quicker. Fine, I'll bring it down then. There we go. And now it's time for the third one. Like this. take this jumper cable and let's see the jumper cable trick. It's my own move. Lump two things together like this. For example. And then it makes it so much easier to solder because I can just solder them like so. There we go. And then we bring this back down and this. Ouch. Looks like a bomb. Thanks. I mean, it doesn't. I can see. Yeah, it's. I can tell. I can see why you say that. Now, right here we have something that's a bit more tricky because we have the ground voltage, and if they were ordered differently, I could just plug it in. Might still be able to. If I do it like this, and if I do, whoop, don't fall over, soldering iron. If I do it like this, and then I take the power cables, and I plug in the plus to the plus, the minus to the minus, like, I can't really plug in the plus to the plus because the freaking plus thing is oxidized to the point where it's basically not functioning. There we go. Now it's plugged in. Now if we do stop restart from machine, oh yeah, turned on. Pin 16 and 18. Pin PWM, and then it's trying its best. 10 PM will be equal to PWM pin number 18. Pin number 18, and then PM frequency will be 50, and then duty will be 60. Oh my goodness, I'm terrified to say that duty because my soldering iron is full. And okay, what happens if I set duty to like 70? 80, 90, 50, and then pin number 16, pin dot out dot value 1. Right, that's enough. You can stop beeping now. You're not depressing anyone. Okay, why isn't this working? Well, I don't know if our special looks like a receiver. ESP32S2 mini out, well, mini doesn't matter, output voltage on a GPIO pin. No single dot I, okay, I see. MicroPython pin out options. Oh wait, Tefta did mention, wait, was it Dia? Oh, I think it was Dia. Pin. It was not Dia. Okay, well, whoops. In that case. Okay, yeah. This output in P0. Low than high. So this high, but we don't need high. We don't need high. We need power. So an actual, like a proper way to do it would be take this. Actually, why did I unplug it? I should just turn off the power supply. I'm an idiot. There we go. So the actual proper way to do it would be to have the ground be like this. The problem is then we don't have a single pin. Plug it in actually. So we need like a jumper cable to go. We need a male to female jumper cable. It's basically gain the gen alpha condition but in a smart way. What? Right, 18. I'm a genius. Well, only if it works. Ow, I shocked myself. Ow, I shocked myself again. Okay, I'm only a genius if it works. But if it works then... Yeah, connection stop reset. Yeah, I know, I shocked myself. I know it failed, clearly. Okay, it's trying to turn, which means now if we do from machine input pin PWM, if we define the PM and then define the frequency at 50, then define the duty at 70, it should be already working. That's a problem. What if we do 115? That's 150, I'm at 115. You suck. I like this. Fine, let's turn off the power supply. What is going on? I'm trying to get this brushless emote to move again. And whilst, yeah, I do have a habit of bringing things back to life, in this case, just straight up not working. I mean, okay. Oh wait, Tefta did advise me to use this. I should do it. I should absolutely and totally do it. Let's do it. So, the way we'll use it is we'll just pop it in on the very edge, like this. And then we can take some jump cables, like so. I almost threw off my soldering iron again. And then we can just plug him in. So in order to plug him in... Oh, this is gonna work, I can already tell. Right, in order to plug it in, we'll need the ground pin, which is the second. We'll need the voltage, And then we'll need this one. Will be our pulse modulated control. Now we take this. It's beeping again like a bomb. Cool. If we do 55, nothing. 75, still nothing. Did I do the frequency incorrectly? Should the frequency be like 5000? No, how about... Oh, this is the correct pin, right? Pin 18. Let's reach the pin 16. If I unplug it, it beats quicker. That's cool. Frequency 50 and duty 75. Nothing. And I get it to work last time. It's the same as the servo, I remember that much. But maybe if somebody knows this, the beeping, you should say it's not a bomb. Isn't a voice for comedic effect? No, officers, it's not a bomb. Trust me. No, it's totally not a bomb. Why would it be a bomb? No. Okay. Huh. So what you're saying is that it should be so from 3 to 12%. Should be 45 too. Do I need like a high voltage or? Okay, it works best with 5 volts. There, 5 volts and 2 amperes. 5 volts, 2 amperes. Duty 75. Let's just do something like 100. Still nothing. Good. It's great. It's great news. The more I increase the voltage, the louder it beeps. And that's just the motor. Okay, cool. We got the buzzer basically, and I'm pretty certain that's actually accurate, considering how it works. It should be spinning now like crazy. Now it should be off. It's not though. Okay, it behaves the same as if I unplugged it. So let me see a diode. Do I have any comically large diodes laying around? Of course I have a comically large diode just laying around. Sweet. I plug it in right here. If I do duty 115, it should be brighter. And if I do 45, it should be dimmer. There is no difference. What happens if I do 1005? Still no difference. Oh, well that's splendid news then. That means it's majorly screwed up. The PWM isn't working. Pin 16 has PWM, yeah. Is it because we're defining it right here? No, that would be dumb. That would be just dumb. pin 16, PWM. Now the diode is ever slightly bright. Frequency 50. 45, 50,000, no difference. This diode right here is telling us there's a problem. Because this diode right now should be practically completely off, and right now it should be really bright. It's not. I can stop beeping now, it's fine. I'm struggling with the diode itself for now. Now it's working, sweet. Alright, PM duty, really high. PM frequency, 50. And PM isn't working. How do we do PM 0? PM 2000 shouldn't be allowed, and yeah, that's correct, it isn't good. Despicable 4, great movie. I haven't seen it yet. Hi, Krish. Why isn't the PWM not working? PWM, just a sanity check, right? Yeah, I am. I can print PM. Pin 16, frequency 50, duty 0 right now, yeah. I mean, post functionality would be shown, right? It do have to be. Hi there, Jonathan. Welcome. Hi. Welcome to live stream. Why isn't the PWM working? How about we switch up pin? Let's switch to pin number whatever. Let's switch to pin number 37 just for the funsies. Oh, wait, wrong one. Right here. I just finished my college entrance exam. Hell yeah! Good for you then. Wait, finish as it passed or finish as in just done? If the second one, how'd it go? This is function 12, so halfway there, which means if we take the random jump cables like this one and this one. Okay, that's good. That's to be expected. And now it should just dim completely, yeah. And now, Okay, so pulse modulation just wasn't working over there. I was working over here, which means now if we take this, if we plug it into the mall, now we set the duty at 50. Still until next year though. Well, you can still relax because you've done it. So now we can sit back and relax. Let's see. Really hope it works. Is it beeping? Okay, that's to be expected. Good. Now we switch up to 70. It works. Wow, it's strong. It's so unbelievably strong. And that's not even all the way. So powerful. Alright, cool. Next thing will be the servo, which also needs pulse width modulation actually, funny enough. And for it we're going to use orange jump cables, as always. I would also need power supply, damn it. Actually, I'm feeling a bit tired today. Even from the inside. Well, you know, there's a comforting thought there. The fact that you're basically done with it, and at this point it doesn't really matter. Like, the exam is behind you, it doesn't really matter what the results are. Yeah, so just take these 10 months to relax. And so a little I actually probably I'm feeling really tired. It's 5 AM, so I feel like it's about as good of a time as any for me to go to sleep. So for now, I suppose. Yeah, so for now be it. Thank you everyone so much for watching, and have a great day. Bye.